is our ICPS project, IoT based engine health predictive maintenance system, and our group is first group, and group members are Arish, Bhaskar, and Likith. Our faculty mentor is Rishikesh sir, and this is the data set we used. We have synthetically created the data set, so that includes timestamp, coolant temperature.
There are features like coolant temperature, oil pressure, RPM, and vibration. So, as per this, we calculated our model and we used the prediction. This is our entire end-to-end pipeline. First, we calculated the synthetic data, as you can see. Then we used our MQTT protocol as a broker, and I've sent our data. As you can, this is the CSV data. We send this data to MQTT broker, and using HiveMQ, you can see here we have a broker and we published our data to here. As you can see, the data went to broker. Then from this, the MongoDB is subscribed, and this get the data of that thing which have 1 lakh rows, and this is having every row of that column which is having in the CSV file. And then we used this data for our project. Using this one, we took this data and done our pre-processing, and you can see we loaded our data set, and then we did our columns, and also we took a model random forest to classify whether the engine health is good or not. And we also did some exploratory data analysis to maintain our data balance. And also then we started doing a model training, which we used is a random forest. So you can see the accuracy for the model is like 87%. The training accuracy is 87%. The testing accuracy is 85%. So this is the best model we used for classification. And then using this data, we forecasted data for next 2 months with the seasonal trends and previous data, how it will be using the random cycle, how it will be the heat spikes and also loads, weekends, everything. All the conditions are come under this case, and we generated the 2 months data, and then we started predicting the failures in the 2 months using a confidence score and the probability. So it started predicting the failures for the next 2 months, which are having more than 87% confidence score, and it is a count of 7 failures. And then we made our project like engine failure is happened due to this reason with a confidence score of this much. As you can see, with the timestamp, we have engine failed at this time due to high vibration, high coolant temperature, and low fuel pressure. So at the confidence of 89%, it is saying the failure is detected. So these failures are took, and then we started sending this data using Python as a client, and there will be a OPCUA server process, OPCUA server, and we use that data results, and we send that to OPCUA server. As you can see, we created a forecast list here. You can see as I highlighted with a access node of a string, and also a name of that node is a forecast list. And then you can see here the string has a values of the results like what we are predicted for the 2 months. And here right side you can see the results like from 0 to 2060, and for the 2 months you can see the results are stored in a array type which is used for this thing. As a part of this, the results also went into a dashboard to visualize the data, where we used the forecasted failures to display, and also the future importance. As you can see, the dashboard. This is the dashboard of our final project, engine failure dashboard, and where you can see the training accuracy and testing accuracy, and also the total rows and failure rate. And here you can see the feature importance, like it will say which feature is more important to predict the engine health. As you can see here, coolant temperature, vibration, and manifold temperature, fuel pressure are having a more percentage more probability to predict the engine health accordingly. And this is the pie chart, like distributing the percentage across the features which is having most contributions to detect the failure case. And these are the manual engine condition checkers. As you can see, the user can enter these manual values like coolant temperature, oil pressure, rpm, and they can see the results accordingly, which values will fail the engine, which values will be keep the engine as a cool. So these are the 60-day failure forecast which will be displayed here, and you can see at a timestamp the failure will be like this with a confidence score of this, so that user can make sure that he can keep the car at that time very good condition. So he can contact the manufacturer earlier or mechanic earlier to remove these problems. So at last we can generate a PDF of the report, and we can check the project which we can check the problems in the car. So this is our end-to-end project which we displayed from synthetic data, and we calculated the engine health predictions. Here we used MQTT as our broker to send our data to MongoDB, which is a subscriber, and also we used OPCUA server, which we shared our engine prediction results as a as an array. So this is our complete project which shares the engine and pipeline.